Hi, let's do some more examples. The cube root of this numerator over this denominator this is going to be an easy one. The cube root, we just do the cube root of the top over the cube root of the bottom from the radical laws and rules. So the cube root of 125 is 5. The cube root of 216 is 6. Now remember about the exponents, since we're doing the cube root, we divide them by 3. In that long example, remember from the previous video, we divided by 4 because we were doing the fourth root at that time. But now we're doing the third root, or the cube root, so we divide all the exponents by 3. We do the cube roots of the 125 and the 216, giving us 5 and 6 respectively. Now we divide 21 by 3 and get 7, so at x to the 21 comes out as x to the 7. That y to the 30th, 30 divided by 3 is 10, so it's y to the 10th. And notice there's no more radical left over. Another way of writing this answer, you can separate out that 5, 6 and do 5, 6 times y to the 7th over, x to the 7th over x to the 7 over y to the 10. But anyway, you separate this from this. Frankly, I like this better just because it's more together, I guess. But anyway, this is correct. Either one is correct, but there it is. So there's that. Let's scroll on down. Now here it's a little more interesting. Notice x squared can't come out because 2, the power, is smaller than the index of 3 for the cube root. But now the 125, of course, it can come out as 5. The 216 comes out as 6. After all, 6 times 6 times 6 is 216. The y to the 30th can come out as y to the 10. It's just that x squared that's stuck. He's the only guy that didn't get to come out. So what we got to do is in the numerator, we leave the cube root of x squared, or you can take it out to the side. When it's out to the side like this, guys, it's understood to be up there in the numerator. Understood. So you can write it like this, out to the side, or in direct numerator fashion like this. Or you can separate the 5, 6 out like we did a minute ago and write it like that. And again, the cube root of x squared is in the numerator. Remember, the cube root of x squared, that can be thought of as x to the 2/3 power, okay? But it depends. Sometimes your professor or teacher will ask you, he or she will ask you to write it in radical form. Sometimes he or she will ask you to write it in exponent form. It just depends on what they ask for. You just have to give them the form they ask you for. Anyway, now let's look at this one. The cube root of x to the 23rd times y to the 16. Well, now 3 won't go into either of these. So we need to find the biggest multiple of 3 that is smaller than each respective exponent. Well, for each letter, we find the biggest multiple of 3 that is smaller than the exponent that goes with that particular letter. So for x, it's to the 23rd power. So 21 is my biggest multiple of 3 that is smaller than 23. And for y, on the other hand, 16, 15 would be my biggest multiple of 3 that is smaller than 16. So I turn 23 into 21 plus 2. I turn 16 into 15 plus 1. So 23 is 21 here and then 2 here. 21 plus 2, aka x to the 21 times x to the 2. Remember, when you're multiplying x to the 21 times x to the 2, you add the exponents if you're multiplying the overall term. Okay, and again from the laws, x to the 21 times x to the 2, that would be x to the power of 23. And in a similar fashion for y, on the other hand, y to the 15 times y to the 1 would be y to the 16. That would take us back here. But why do I want to fragment it like this? I want to go the other way. I want to leave it fragmented, though. Here's the reason why. These two guys on the left of the times sign can come out, whereas these two guys on the right, namely the x squared and the y, they cannot come out. So the x to the 21 comes out as x to the 7, times the y to the 15 comes out as y to the 5th power, times the stuff that couldn't come out, the cube root of x squared y. This guy right here that could not come out. He's stuck inside the radical, and he's not getting out. So there's that. Now, so these are just some examples of things when you can and can't escape. Okay. Now, let's say that I have like radical 2x times radical 3x. Now, that's going to be we're assuming all variables are positive. As always, I should have said this earlier, in all these examples we've been doing, well, for the cube root, it doesn't matter as much, but let's just keep it tit for tat. For even roots, it very much matters. Let's assume that all variables are positive, okay? Let's assume that x, y, z, or any other letter you see is positive, okay? Always assume that unless I otherwise come out and say so. Okay, so radical 2x times radical 3x, that's radical 6x squared. As long as x is positive, this is valid. If x wasn't positive, this wouldn't even be valid. But anyway, it's valid because I'm assuming x is positive. So radical 2x times radical 3x, that's radical 6x squared. But remember, x squared comes out as x when x is positive, and it is. We're assuming it always be. So we got x radical 6. Now, you can write it like that, or you can write it as radical 6 times x. Be careful if you write it like this. Be careful when you're typing or writing. You don't want to put the x inside the house. The only thing inside this house here is the 6, not the x, just the 6, okay? Anyway, and notice that the square root of something times the square root of something ought to be the original something. So radical 3x times radical 3x, that ought to be 3x. Well, by the rules, it equals radical 9x squared, but hey, the 9 comes out as a 3, and x squared comes out as an x, and we get what we expected to get. Well, it's consistent, okay? Now here, be careful, radical 2x plus radical 3x, it won't simplify. That's not to say it's illegitimate. It's perfectly legitimate. It's just, as a process, it's just that this won't simplify. You can't call this I know what you might want to do, and you can't do it though. Most of the time, this will not equal radical 5x. You cannot say this equals radical 5x. Don't do it. You just have to leave it like this. Now later on, we can do some trimming. Like if you do radical 2x plus radical 8x. Oh, next example. The later didn't come very much later at all then. So let's go down here. Let's move on. Radical 2x plus radical 8x. Now remember that 8, now this doesn't look like we can do anything, but we can do more than it seems. Because that 8x is 4 times 2x. I'm just doing associativity and all that stuff, commutativity. Associativity, I think, in particular here. So, but now the square root, 4 comes out as a 2. The square root of 4 is 2. So that 4 turns into this, when it comes out, it's this 2 right here that's outside. So I get an understood 1, I get radical 2x with an understood 1 right here that you can put that 1 right there like that, but we rarely do. So we got 1 rad 2x plus 2 rad 2x, that equals 3 radical 2x. And by radical, I mean square root, okay? So there's that. Now notice now, guys, these are like terms because you like 1 radical 2x plus 2 radical 2x, that's 3 radical 2x. 1 times whatever plus 2 times that same whatever is just 3 times that whatever. 1 times gobbledygook plus 2 times gobbledygook equals 3 times gobbledygook. And I'm just using bad English here, or invalid English, I should say. But there's that. But anyway, now let's just say if you ever have anything, if you have like 8 radical 2x plus 7 radical 2x, that would be 15 radical 2x. You can add them like variables. If they're like terms, you can add them like terms. I don't see any harm. Let me just go ahead and do something similar to that. And likewise for the other roots. Now the roots have to match. You can't, like the cube root of 2 plus the square root of 2, you can't simplify that. But if you have something like let's look at this. If you have like 8 radical 2, and let's just say I do, let's say I do minus 5 radical 2, that you just subtract the 8 and the 5, you get 3 radical 2. Like that. Or if I want to mess with it and put some x's inside here, like that, and like that, that's fine. Just so they all match. All these need to match. That's huge. It would not be valid to delete an x here and to not delete an x here. That would, they would be non-simplifiable. So I couldn't do this. So it's important they all have to match. Like if you wanted to put xy, let's just say you want to do something kind of weird, assuming all variables are positive. But anyway, there it is. And the whole time we're going to assume all variables are positive anyway. Okay, but they all three have to match, okay? So there's that. Now let's scroll on down. Like if you've got radical 32 minus 7 radical 2 plus radical 27. At first, this looks totally hopeless. Now, we can simplify this somewhat. Maybe not a total breakdown, but we can simplify this a good deal. Now, you want to find since you're doing the square root, you want the biggest perfect square. If you were doing the cube root, you'd want the biggest cube, or fourth root, the biggest fourth power. That was back when we was doing the 6250 from the last video. But anyway, let's look at the square root. We're looking for the second power. So the biggest perfect square that'll go into 32 is 16. So you break up 32 into 16 times 2. And now minus 7 radical 2, there's nothing to mess with. You can't really do anything with that. Now 27, notice you can turn the biggest perfect square that will go into the biggest perfect square that will go into 27 is 9. So you turn 27 into 9 times 3, okay? So, but what happens is, you see that 16 times 2, the 2 can't come out, but the 16 can. The square root of 16 is 4. The 2 stays in. The minus 7 radical 2, you just bring it down, it's stoic for now. And then the plus, now that 9, square root of 9 is 3, so that comes out as 3 radical 3. Now guys, we can only add what matches or subtract what matches. Now 4 radical 2 minus 7 radical 2, that would be neg 3 radical 2. But we still got this plus 3 radical 3 dangling on. And it's going to stay that way though. There's nothing else. It's going to stay dangling on. We can't mess with it. We can't add this anymore. That's it. This will not go any further. Notice this is a radical 2 term, but this is a radical 3 term. These radicals have to match in order for you to add. Like if this would have been neg 3 rad 2 plus 3 rad 2, I'd have gotten 0. But that's not the case here. This is 3 rad 3. The radicals don't match, so we can't go any further. This is it. You can write this in different. I'm not claiming you can. You can write this in different formats, but you can't really truly simplify it any further. Okay, so that's as far as you can go. Now let's look at this guy right down here for the next example. The cube root of all this. Remember, you just do the cube root of 216, you get 6. And you remember, since you're doing the cube root, you divide by 3. X to the 6 comes out as x to the 2. You divide this 6 here by this 3 here. So 6 divided by 3 is 2. And then you divide all the exponents by the index 3. Now y to the 42 divided by 3 is 14. And then z cubed. Now 3 divided by 3 is 1. So what's downstairs stays downstairs. What's up stays up. So here's z to the 1 downstairs. But that's just z itself. And then 300 divided by 3 is 100. So that w to the 100 down here. And let's stop the video there. We'll move on to the next video. Thank you.